Good afternoon. Thank you so much for joining us today. My name is Nicole McFarlane-Home. I'm joining you here today from Corporate Risk Solutions. And if you are listening right now, you know that you are here to get started on the educational webinar that we put on monthly. We want to thank you for being here today. This particular topic, drone threat to the bulk electric system, is a really exciting topic. As all of you know, it's not yet been formally addressed within the NERC environment, but this is a forward-thinking program. We're going to go ahead and get started here. I do want to provide you with a little bit of just housekeeping information. We are going to try to keep this within 1 hour, 50 minutes approximately. There are some handouts. If you look to the right-hand corner of your screen on the webinar control panel, there is a section there that has questions, handouts, and chat. The handouts actually include some directions on how to use the chat. It gives you information on the speakers' bios themselves, and also some input on our recently updated 3rd edition of our compliance guide. So there's a lot of information there for you. We would ask that you are going to submit questions during the presentation for immediate answers. We're going to have somebody standing by to answer those for you. But at the end of the survey, if we've got some extra time, we'll open the floor for some questions. And you can certainly email myself or anybody that is on. You'll have that contact information at the end. I do want to go ahead and let you know that there's going to be an auto survey that pops up at the very end of this program. We'll be sending that out to you in an email additionally. The webinar slides, a white paper, and the recording are also going to be coming to you delivered via email to all attendees today. I want to go ahead and get started here to introduce you to our primary speaker today, Mr. Gary Hetrick. He is a highly experienced physical security consultant, years of experience. He's really excited to tell you about the program today. We've also got Luke Mahoney, who is a highly experienced security compliance analyst who does a lot of projects of physical security as well. He will be the subject matter expert that's actually available to answer your questions today on the chat. Without further ado, I want to thank you again for being here today with us, and I'd like to go ahead and pass it over to Gary. Gary?
Good afternoon. I'm Gary Hetrick. Thanks, Nikki, for that introduction. I'll fill you in some of the blanks of my background. I've worked a number of programs for force protection, both in and out of uniform. This includes duty in Iraq with the U.S. Army Asymmetric Warfare Group, where I focus on efforts to counter improvised explosive devices, IEDs. After I retired from the Army, for 7 years I worked for the Navy as a contractor integrating training programs to counter IEDs and like capabilities. This included conventional Army Marine forces as well as Special Operations Forces. Since leaving the Department of Defense, I've worked as a physical security consultant for Corporate Risk Solutions. And as of this week, I've got a grand total of about 25 threat and vulnerability assessments under my belt. 24 in the electric power industry and 1 with the chemical industry. Thanks for the questions from registration. I appreciate those. I think by the end, I should have answered 90% of those when I reach the incident you see listed there, when you understand both the threats and the possible mitigations to the risk from drones. One question I don't have an answer for is what other electric power industry partners are doing to use drones themselves in a counter-drone mode. I just have no feedback on that right now. From a problem statement, take a second and take a look at that. You see the situation. Drones can exploit the basic and advanced security measures that are now currently protecting our substations. The problem, of course, is how to solve that. You see the actual, the thing that got this all started was from the DHS. That report came out originally in 2004. They went through that and completed it in 2007. And then in 2012, it was actually released, at which point in time, it almost coincided very closely to the Metcalf incident. At that point, we started seeing SIP 14 emerge. 3 reports of note that came out very recently, within the past year or so. I'll focus your attention on the top one there. The one that came out in May from the Office of Cyber Infrastructure Analysis. And basically, what they focused in on was the threat that is available to both drones and other non-aviation assets. And the key to that is they can target large population dense areas, exposed chemical storage systems, and exposed electrical transmission and distribution pipelines, lines, and other measures.
Excuse me, really quick, I'm so sorry, Gary. Technical difficulties. Could you double check real quickly to see that you could scan through the PowerPoint right now? We're just seeing the cover page.
Can you see it now?
No.
Is it available now?
That's perfect. Thank you so much.
Okay. So that brings us to the scope of what I'm going to talk about this afternoon. We're focused on SIP 14 basically, and that's threat and vulnerability assessments, and specifically those that threaten the bulk electric system. Key to that is how the design basis threat is arrived at, and that's used to actually determine what threat you're looking at, and we're going to take a look at how drones play into that. That threat definition is a foundation for assessments and security plans, and that can be listed out very well in SIP 14. A key quote I want to take from Paul Scher, you can see it there in yellow. We've been in the environment where IEDs are something we go out and look for and try to eliminate. Now that has changed. The IEDs are now looking for us, both whether they're lethal or they're just in the form of surveillance. What I'll walk you through now is the attack planning cycle from an anti-terrorism standpoint as well as a terrorist standpoint, so spy versus spy, so to speak. On the anti-terrorism side, what we are doing, we conduct our threat and vulnerability assessments. We implement the security measures to mitigate those risks. We actively are in observation mode, trying to detect the terrorists trying to make an attack or aggressors trying to penetrate the wire, the perimeter fence line. We do random actions to keep them guessing so they can't see a set pattern, because once they see a set pattern, they can formulate their plans to very precise measures. And of course, we work on response planning. That's all taken from Ross Johnson. He's a Canadian, and you can see the name of his book right there. It's a pretty good way to explain how both the friendly and the not so friendly folks plan their operations. From the aggressor standpoint, or the terrorist, he's going to conduct his broad target selection. He's looking to further develop that so he can pick out a specific target. Then once that's selected, he's going to go to pre-attack surveillance. He wants to find out the very specifics of that location, so to speak, which way does a doorknob turn? He wants to figure that out. Then he'll go into his attack planning. The drones can most help him in intelligence surveillance and doing that final close target surveillance or reconnaissance to determine the details on target. He can also use drones for propaganda by filming the event and using it as part of his propaganda. I'm going to transition now to the threat basis design. I've listed out the parameters I'm looking at in terms of how to take a look at drones and how they impact upon our threat assessment. I've limited them to a length of 1,500 yards to do their run to the target. He does get some standoff so the operator does not have to be close to the target. So close target reconnaissance is now possible with a standoff of 1,500 yards. He can stay on the target for up to 15 minutes. He can deliver a payload with very precision to exactly where he wants it at the location for either surveillance or to deliver a payload. The maximum payload he can take is about 4 pounds for the typical commercially available drone that's under $6,000. And that drone could actually penetrate a half-inch thick of exterior plate, whether that's the plate of a transformer or some other critical asset on the location. Now, in terms of specific SIP 14, the idea is there will be multiple attacks against the bulk electric system, not just one attack against one substation. So you have to consider this part of a bigger overall plan. We can compare that to the study done by the Cyber Infrastructure Analysis Group from DHS. And that's what they came up for their threat basis design. Similar in terms of weight, time of flight, and distance from the controller of the drone. What I'll walk you through now is a SWOT analysis: strength, weakness, opportunity, and threat. I'm going to take you through this from a threat perspective, as if I was a planner, an aggressive planner. From a strength standpoint for a drone, I can get it off the shelf. It provides real-time intelligence. I get standoff, and that's the most important aspect from a surveillance standpoint. When I do my close target reconnaissance, I do not have to be exactly standing on top of the target to see what kind of locks are being used, or the gaps in the fence, or the places where there's hidden parts from the actual surveillance system. I have precision delivery of small payloads. I can train other operators to use this. It comes with weaknesses. Although it's relatively inexpensive in terms of cost, if I acquire a lot of these, it could highlight the fact that I'm trying to do something along these lines. So I got to be careful of how I spend my money. Very limited lift capacity for a payload. Very limited range to the point of attack. And I have very little time on station to get the information I need or to place the device where I want it to go to. And again, I'm hoping the skilled operator will overcome some of those weaknesses. The opportunities that a drone can provide me as an aggressor: it reduces my risk associated with getting close target reconnaissance. I can avoid the substation camera orientation. They'll never know that I'm getting inside to get the information I require. And the big opportunity are current U.S. legal issues from both the FCC and FAA, because they limit the U.S. ability to do electronic attack and jamming outside of the Department of Defense. From a threat standpoint, to me, as a drone operator, I'm subject to electronic attack, the physical barriers found on the location, and of course, someone on target could shoot me down. Whether that's legal or not is what my concern is, but it's possible you could do that. All total, from a SWOT analysis, the drone becomes a very effective tool that I can place into my inventory and take advantage of as an aggressor. The surveillance payloads available to me are pretty outstanding. Just the standard capabilities of the cameras that come with a purchased drone are pretty remarkable. You see two common types on the left, both DJI products, and the upgrade, both very capable. I could further upgrade to additional cameras that are even more capable, up to including a FLIR for under $1,700. So I have both day and night capability as a possible solution to my problems if I'm a drone operator. And what that really can be, besides surveillance, are the hostile payloads. They're both destructive or disruptive. I'll cover disruptive first. What you see in front of you is a substation. We're all familiar with it. Plenty of transmission lines are exposed. And what that exposure really lends themselves to is a conductor being placed upon them to cause the system to trip. Whether that's chain, cable, whatever could be delivered, if I cross those, I will trip the system and cause the grid to have a hiccup. Enough hiccups and we have a problem further on down the line with cascading effects. But bottom line, drones can assist me in getting conductive material over top of those lines. From a destructive standpoint, we can use an IED of sort, an explosive improvised device of some sort, but the most dangerous would be an explosively formed penetrator, an EFP. These were introduced into the Iraq war from Iran. And basically, it's a very simple explosive device, but it's a shape charge. It's a PVC pipe about 6 to 8 inches in diameter, has a copper platter formed at one point. At the business end, it's stuffed with explosive, and a blasting cap at the other end with a trigger device. The explosive material can be military grade, it can be homemade explosive, or TATP. That's the type of explosive the terrorists in France used on their assault most recently. And that can be built with products purchased from a local drugstore. The downside with that particular device, that explosive, it's very volatile. In many cases, the guy who builds it winds up blowing himself up. But it's an option that can fly underneath the radar and be used to make an EFP. This device is very small. It's under 1.1 pounds per plastic explosive. And it is an overmatch for rolled homogeneous steel. The picture you see is of a commercial version called the Krakatoa. That's produced by a British firm for military use. I've listed the actual YouTube page, or you go to that home page to see more details. But the bottom line is the effects it can produce. That small device created that hole in that 1-inch thick piece of rolled homogeneous steel. So it's a very effective weapon. It has quite a bit of penetration. It can be delivered by a drone to a place of opportunity. And then, of course, if that penetrates a transformer, you can imagine the cascading effects. With these kinds of details, I will now walk through the design basis threat, especially with the use of a drone or different explosive or disruptive devices. On the left-hand row, you can see the attributes of the cell or the organization. Across the top, the 3 types of organizations for the threat. Low being just local thieves or protesters. Medium being homegrown terrorists or eco-terrorists, maybe even lone wolves. On the high end, international terrorists or state-sponsored terrorists, Hezbollah, Al-Qaeda, or ISIS. The key separation between these 3 groups is capability and intent. The guy who's conducting the theft could use a drone to scope out the gaps in the wire, the earlier cuts in the wire, and the location where the cable lies inside the perimeter, so he can further plan his theft. The medium threat is looking not so much at a lethal intent, but non-lethal intent, trying to possibly disrupt the power system for a particular company, or to create an effect where they can use for propaganda. This would mainly be with not just surveillance, but also capturing the event on propaganda by filming it from a drone, or possibly using a disruptive nature to cause disruption for that particular company. At the high end, obviously that's state-sponsored terrorism, ISIS or Al-Qaeda. They'd be looking at a lethal capability in terms of trying to disrupt the bulk electric system for a long-term outage. And those threats can be placed into scenarios. I don't want to go way down the weeds in this, but the typical scenarios are surveillance. And what I really want to point out to you is a probability of their likelihood. The surveillance is fairly high. In fact, I know it's actually been taking place already in the country. You can almost anticipate that happening at any given substation. Protests, we've not yet seen the use of drones in the United States, but it's easy to see they've been used overseas. I can anticipate those being used possibly for disruption, but most likely for propaganda purposes. A local outage, that's a low probability in my estimate, but it could have some impact on shareholders. We get down to destructive scenarios, low probability, but the impact is very large. You could destroy transformers for $2 million apiece with a very asymmetric capability. If it's an orchestrated event, multiple attacks, very low probability, but a very high impact in terms of the bulk electric system going down for a long term. So in terms of looking at your risk, you consider your probability, compare that with the impact, and see what you're willing to live with in terms of what risk is available, and try to mitigate that risk to something you can live with. Now we'll take some time to look at threat mitigation. Mechanical, electronic, and then the challenges of both. What you see in front of you right now is a dome over some device. I'm just saying that conceptually you could protect your system with something overhead, mechanical barriers. You could use electronic attack or other ways of trying to mitigate the effects of a drone coming in. by either jamming the command links, disrupting the payload, or coming back on the way back, disrupting the GPS grid coordinates. And the challenges are mainly coming from the FCC. Mechanical mitigation, threat mitigation from mechanical means. The overhead obstacles you could in place aren't necessarily chain link fence across the entire substation, but some sort of barrier in terms of a mesh that's large as maybe 1 foot by 1 foot wide. It could be cabling, it could be rods, any number of things, with the essence of what you're trying to do is prevent a drone from precisely placing an explosive device or delivering some kind of carbon fiber strings or cabling on top of the transmission wires. Drone interceptors have been attempted, but I don't know of any successful use of these. And that's somebody on site with a drone, with that attachment you can see a net, trying to net the other drone to keep it or swat it away or trying to capture it. And of course, you can shoot them down, the Elmer Fudd approach. Right now, this is some serious problems, not with the FAA, but if any of you have ever been hunting for waterfowl, goose, or ducks, you're very well aware of the limited range of a 10 gauge or a 12 gauge. You could use other capabilities, but your range is limited, and you have to have them available on the target you're trying to protect. There are different other methods for technology to mitigate the risk. Acoustic sensors can indicate the surveillance. They can actually detect the approaching drones. You can install no-fly zones in the firmware of the thinking portions of the drones themselves. DJI has already done this with 10,000 no-fly zones in their drones. Now, what that would mean, you would have to provide the Chinese the locations of all of our critical substations for more no-fly zones. I don't think that's a very good idea at this point in time. You can go more high-end with compact radars. They are great for detection. They can activate other countermeasures to interdict the drone. You can jam GPS signals to prevent navigation to the site. You could jam the command link to prevent commands from directing the drone where to go to and what to do, or perhaps even take it over. If they jump to multiple frequencies, you have to go to a multi-frequency jammer, much like we did in Iraq and Afghanistan. Then if ultimately there's command link hijacking. That's basically like a Wi-Fi attack locally, where they get inside the Wi-Fi signal, take over the device, then take control of it and land it where it needs to go, or intentionally crash it. You see that weapon right there? It looks very impressive. It's actually a weapon for doing command link hijacking, with the guard actually using it against the drone. There's many challenges. Both the FAA and FCC have laws and regulations that are causing major implications in terms of how we fight drones in the United States. In terms of electronic attacks, what you're affecting are public frequencies. So even though you're trying to attack the frequency used by a drone, you're also impacting the frequencies for emergency response and other measures. And obviously that's a major law that has to be worked around and compromises made. The same with GPS interference. Yes, you're disrupting the navigation of that drone, but you're also interrupting the navigation of emergency response to someone close by, but also not just on the ground, but in the air to aircraft flying overhead. So there's many collateral damage effects caused by jamming. In terms of regulations and restrictions, on the FCC website, you can see the actual regulations against jammer enforcement. And it's very, very restrictive. If you were to use shotgun fires, kinetic fires of some measure, there's liability. If you shoot the drone down, it falls on top of somebody, that's a liability you have to answer to. That could be offset by insurance, but bottom line is it's a problem you would have to anticipate and think of ahead of time. In fact, the FAA has recently come up and publicly stated that shooting down of drones is illegal and against the law. Specifically, Code 18 of the U.S. Code 32. And off a website, you see what that actually is. It is lumping anything that's a drone in together with all other aircraft. It's against the law to shoot those down at this point in time. This can be changed in the future, but as it stands right now, it is against the law. So that leads us to take a deeper look at the technical solutions that are currently available. And those are the four major ones: passive acoustic, radar, electronic attack, and combinations. Drone Shield is an acoustic system. It can actually listen for the sound of the drones, characterize those drones and tell you what specific type of drone it is, identify it, and pass to you the general location and what the perceived intent of the drone is. And it sends that to you by SMS text message, email, whatever mechanism you want to use. The short-range omnidirectional sensor, or a longer range, very restrictive cone of a 30-degree angle, but bottom line, a 1 kilometer range. So if you were to protect a substation, so to speak, you would need up to 9 to 10 of these around the substation to have full coverage. Again, this is passive. It's not violating any laws or regulations. Very effective tool. SRC is a Syracuse research. They have a long history of electronic attack and radar for the Department of Defense. They have splintered off Griffin sensors, which is non-military technology, to adapt to this type of mitigation. Again, their military capability is very capable, but they've transferred that to a non-military solution. It consists of a primary radar. As you can see, it's got quite a good range, 8.5 kilometers for a drone, small drone. It does some analysis. It pieces that together to reduce the false positives. It can then slew a camera or some other device to engage the drone, whether it's taking pictures or using a spotlight or whatever you want to do with that device to try to engage that drone. In this version, it's legal and meets all the regulations. If you change the effect to being something along the lines of electronic attack, that's what's against the regulations currently by the FAA. Blighter is a UK firm from the United Kingdom. They have a similar capability, but it's mainly militarized. You see a basic picture of it there. It's very, very capable. It can track up to 700 targets. Its range is pretty phenomenal. It can reach way out there and engage the target and take either FLIR pictures, CCTV, or engage it with a command link jammer or command link override. There's a picture of it in the field in operations. It has been used for some high-level protection of international assets to date. And that's what the operator at your security operations center would be looking at it on a screen. The key to both systems, both from the SRC and Blighter, they require quite a bit of training for the operator. Or you could use their operators at your location. But you have to consider the overall cost of those capabilities. Spotter RF is a Honeywell firm. They have Blackwell's Black Sage technologies. It's very similar to the other two programs, slightly reduced range, and it uses their Spotter RF radars. And here you see it engaging a UAV at night with a bright light. In the future, based upon changes in regulations, that could be any number of engagement capabilities, but for right now, you're limited to picture taking or shining a bright light on the UAV, the drone. The Drone Defender, It's a much more aggressive look. You see a very large weapon system there that can engage the drone, take control of command link, and determine where to land the drone for further use to reduce the threat from the drone. It's got a range out to 400 meters. The drawback is the U.S. government has 100 of these that are currently being used, but only under their requirements. It's not available to the general public or commercial employment. Right from their website, there are restrictions. It's illegal to use this weapon outside the Department of Defense or the U.S. government. I've talked about a lot of great capabilities, lots of restrictions. Here's a laydown to take a look at the alternatives. At the very top, the very simple mechanical method of providing some kind of protection for the substation or critical assets. It provides a deterrence, and in fact, it physically protects your equipment. So it would be functional. In yellow, you see the items that provide the awareness that the drones are there. They can detect and communicate their locations, help you assess. However, they don't do anything to stop what the drone is doing. Then down on the following more attractive solutions, they'll have limitations in terms of legal issues. Whether you're shooting them down, jamming, attacking the command link, or you're integrating all this stuff into a single package. There are legal restrictions. At this point in time, I want to come to a conclusion. If you haven't read the article or from the Office of Cyber and Infrastructure Analysis, I recommend you do that. That's available on the Homeland Security Information Network. And basically what it's saying, key targets, vulnerabilities can be exploited by drones. And these include electric transmission facilities and transmission wires, as well as chemical storage systems. They're both subject to being affected by drones. At this point in time, I'd be happy to take any questions. You see our contact information listed on the screen for myself, Nikki, or Luke. Are there any questions at this time?
I would actually ask that you go ahead and open up the floor so that people can talk. We've got some people raising their hands, it looks like, but they're not going to be able to use. We can unmute them is what we're going to need to do.
So are we making them?
Hold on one second. Mike, do you have a question? We've got a question here. It's written, it says, why is there a difference between engaging a threat on the ground versus in the air? Shouldn't they fall under the same criteria?
Yeah, I'd be glad to answer that. I think the difference is the controlling mechanism being the FAA versus local law enforcement for ground action. So we have to respond to regulations based upon the FAA. Does that provide the answer you're looking for?
We're having some technical difficulties trying to give Mike the actual floor so he can speak. Sorry about that. Okay, yep, he answered. That was a good answer for him. Thank you. Are there any other questions anybody would like to put on the chat board or raise their hand and talk? We do have one other question here. Gary, would you revisit how drones are currently being used or developed to protect facilities, other entities?
I am not aware of anybody actually producing that capability or using that capability. Drones themselves in a counter-drone method other than the net.
Gary, this is Hartford Field. There are some of the utilities, the corporate security entities, that are beginning to acquire them to use as almost like a red team approach, to be able to do their own analysis and tests of their procedures, even though they may not have yet implemented actual anti-drone mitigations. So it has begun, and they recognize, many recognize that it is an evolving threat for the electrical utility industry.
Thank you very much for that additional information, Hartford. We do have another question here. It says you were talking about the shape charge earlier. Is that something that has to be physically attached to a critical asset, or does it just need to be dropped near it?
I would see that being in place close by, up to 25 meters away. It doesn't have to be right next to it. It can use standoff, but it has to be correctly positioned so it hits its intended target. I don't think it would be dropped. In fact, if I was the aggressor, I would just land the drone with that shape charge and lose the drone in the explosion.
Excellent. Thank you, Gary. Great question, Ingrid. Thank you. We still have some time. Is there anybody that wants to enter another question in the chat that we can address while we're here together today? Okay, well, I want to thank you again for joining us today. If there's no further questions, I just want to thank you for being here. My name is Nicole McFarland-Holm. You've got Gary that was talking to you today, and Luke was answering some questions on the chat. Oh, I'm sorry. We're going to go ahead and have Gary wrap it up for us, and then I'll give you some information again at the very end. Gary?
Sure, Nikki. Okay, I think we've attained our purpose here today. We recognize drones as a threat to the bulk electric system, and there are mitigation to mitigate the risks of drones. However, they're all expensive and difficult, and this is not an easy target set to go against. And it's going to be a challenge for us in the future for looking at from threat assessments, but also how to mitigate the risk. We've covered the outline. I was very happy to answer the questions. I appreciate those. And thanks for attending today's webinar. Well, back to you, Nikki.
Well, thank you so much, Gary. Just wanted to point out to those on the phone, we do have an updated website. We'd love for you to stop by, take a look at the upcoming events, and get registered. As we mentioned at the very beginning of this call, we do offer these educational webinars on a monthly basis. We'd love to have you come to the July 20th presentation, which is going to be on conducting a cyber vulnerability assessment. We've also got something lined up for August on audit preparation. So I would have you take a look and get registered now. Those seats fill up very quickly. I'd like to remind you here in just a moment, a survey is going to pop up on your screen. We will be also following up with you within the next 24 to 48 hours to give you additional information. A couple people asked about the slides. You will get the slide deck, you will get the recording, and we'll be putting a white paper in the emails as well. So you'll get that email from myself personally, and if you've got any questions, feel free to respond, and we'll be in contact. Thank you again for joining us today. Have a lovely afternoon.